When we speak to our customers and ask them what problem we're solving for them, it's always the same thing. Our customers want to enable their employees to access their apps wherever they are. They want to bring the public cloud principles to their private cloud. And it's not just about launching a VM. It's about launching a full workload. That means configuring the network, implementing security policy, the load balance of scaling, and more. These solutions all have APIs, but it's still difficult to automate. And the reason it's difficult is that the APIs are at a primitive level. We all know that partial automation means a ticket, and tickets take time. And I know this because I run software development for the 6th largest software company in the world. What our developers need from infrastructure is agility and automation. When they launch a workload, they want it to work and not have to open tickets and wait for weeks. With over 2 million containers and well over 1 million VMs set up and taken down every week, automation is key for us. Because we are fully automated, even during this global crisis, there was no impact to our productivity. The traditional networking model is about connecting boxes in campus and branch and data center with little attention paid to the apps running on top of the infrastructure. The modern network flips this on its head, taking the bold view that infrastructure exists only in service of the application. Let's look at this approach. There are 3 pillars to a modern network architecture. The first is that the network needs to provide the connectivity needed for modern applications. The second is that all network infrastructure services in a virtual form factor spanning across on-prem and cloud infrastructures. And the third is the actual silicon that moves the bits. And as always, we need security across all of these. Done right, that delivers agility and saves money. Let's dive into the first pillar, modern apps connectivity services. What we really want here is the ability to specify parameters for the user device to app experience. Think of it as sliders that you set, and the infrastructure underneath adjusts to support and enforce those objectives. And one of those objectives is security. Let's look at security in the context of a distributed workforce. In the old world, if you had an employee in Sao Paulo working from home and doing a Zoom call, that traffic would get backhauled all the way to a data center DMZ in New Jersey. And that's because all the boxes that did security were located there. And then onwards to Zoom running in the public cloud. We would do this using dedicated security appliances, firewalls, web security, and more that were deployed in that DMZ environment at a few points of presence. Now, imagine if we take that DMZ infrastructure and broke it into hundreds of pieces and placed those in points of presence all around the globe. Instead of moving the traffic to where the services are, we move the services to where the traffic is. Now, the traffic can go directly through the nearest point of presence, and the security will be applied there prior to handing off the traffic to its final destination in the public cloud or in the data center. Reducing latency is make or break for user-to-app traffic and the interconnection of things. 5G and edge computing go hand in hand to enable how latency across the WAN is kept low as part of an on-demand network stack. So this approach provides a significantly better experience for users accessing their apps from wherever they are, while building in security distributed into that infrastructure. Let's move on to multi-cloud network virtualization. To get the infrastructure to support the user and the applications, you need a full network stack across multiple clouds. It must go beyond just switching and routing to include advanced load balancing and firewalling, enabling virtual machines, containers to all communicate. And if you want to measure end-to-end application performance, you need to use a software stack that spans all the way across the wide area network. Else, you get partial automation. And as we know, partial automation is an oxymoron. And network services are most efficient and effective when run close to the workloads. Now, you need automation at the time of initial setup of the workload, but you also need it for ongoing operations. This is where a lot of time gets spent. You want to be able to automatically detect issues and more, fix problems automatically at scale. And you want to do this across private clouds and public clouds with one consistent set of policies and cloud management. Last but not the least, let's talk about that physical network infrastructure. This is what most data centers look like today. We see this moving to something that looks more like this. This is what the innards of a cloud data center look like. And when we run our software-based distributed firewall across thousands of hypervisors, running across tens of thousands of cores, we can get 20 terabits per second of throughput. That's an order of magnitude more than the largest hardware firewall. And we can deliver this at 3x lower cost. Similarly, with our advanced load balancer, we can auto-scale and deliver 1 million SSL transactions per second. This is also an order of magnitude more than the largest hardware load balancer. In both cases, it is scale-out software running on commodity x86 hardware that eliminates the need for special-purpose hardware appliances. And looking out at the near horizon, we have smart NICs, or smart network interface controllers, that take this even further. Smart NICs are essentially powerful NICs that include significant compute horsepower and accelerators to handle networking, security, and storage functions. We still need the physical layer to move bits rapidly from point A to point B. So the physical network becomes all about providing high capacity, low latency connectivity. Keep it simple and let the software do its job on top. Implement your network policy and configuration and software, which allows your network to become code. Policies can get coded and built into the CI/CD pipeline. So, we've defined the 3 pillars of the modern network with the 5 supporting tenets. The virtual cloud network is VMware's embodiment of the modern network. It's about any app to any cloud to any device anywhere. The VMware virtual cloud network is mature and proven. If you look at the results, we must be doing something right. We have 18,000 plus customers, 91 of the Fortune 100. 8 out of the top 10 telcos use us. We are deployed in 280,000 branches around the world. Thank you.